Hi, I'm Ms. Fung. Let's have a look at cubic functions in the factorized form. So the factorized form looks like that. 3 factors because it's a cubic. And you can have 1, 2, or 3 intercepts. But in this scenario, we'll have 3 intercepts, depending on what A, B, and C are. Now we notice that the y-intercept, when x equals 0, will be just negative ABC. So here's a graph to describe that. So you'll have 3 intercepts, ABC, and the y-intercept is whatever the 3 numbers are multiplied together, and it's negative. And what does the negative graph look like? Well, the negative graph looks like it's flipped over the x-axis, and it'll look like that. So this is an odd graph, like the power is 3. So you're going to think about it like linear. Remember linear? If it's positive, it's going up. And if it's negative, it's going down. So with cubic, it's the same thing. When it's positive, it's going up. It starts with going up. And when it's negative, it starts with going down. So let's do an example. So let's sketch this. It's a positive graph, x times x times x. So you look at the biggest term and you see that it is positive. So the whole graph will be positive. So it's going up. Oh. So the y-intercept will be minus 2 times 3 times minus 5, which makes it positive. And the x-intercepts are there. So 2, 3, and negative 5. So we can sketch that. So it's a positive graph, so it's going up. Put in the x-intercept from smallest to largest. The y-intercept is over there at 30. So example 2, this time it looks a little bit different. Notice that this is squared, so we're going to have a turning point at the x-axis. So now we have a negative graph. And how is it negative? Because x times minus x is negative x cubed. So our graph is going to go down. So y-intercept, x-intercept, y-intercept is 1 times 1 times 3. Or in other words, let x equal 0 and you can multiply 3 to convince yourself that's 3. And the x-intercept is negative 1 and 3. But the negative 1, don't forget, it's got a square, which means it's a turning point. So how would we sketch this? So it's a negative graph, so we go down. And at negative 1, you can see that's a turning point. And at 3, 0, sorry, that part there, it's an intercept, so it just goes through. So to clarify, whenever you see just an intercept, then your line is going through, like so. Whenever you see a turning point, then you get to it and you do a U-turn. And then the y-intercept, just stick it in. Example 3. This time we have x minus 1 all cubed. So we have a positive graph because x times x times x is x cubed, positive. So it's going to be going up. And we notice that it's a point of inflection. So the y-intercept, let x equal 0, we're going to get minus 1 cubed is minus 1. And the x-intercept, let that equal to 0, so x is equal to just 1. And that is a point of inflection. So let's sketch that. So the point of inflection 1, 0, and our y-intercept at 0, negative 1. What about in that format? I think that's the scariest one. So we notice that we can factorize it. You can do so with a CADS calculator, or you can go back to the video on factorizing. And now we notice that there's one x-intercept and this part has no intercepts. So what does it look like? Well, let's figure out the y-intercept first. Let that be 0, 0, 0. So 1 times minus 3 over 2 is just minus 3 over 2, or minus 1.5. For the x-intercept, we have positive 3 over 2. And that doesn't work out when you let it equal to 0. So now we can see from the graph that it is that one x-intercept that we found, the y-intercept, and the rest of the graph is underneath. That's why that one is, you cannot factorize. You can check using the discriminant. So let's recap the 4 formats that we have shown in brackets. So this one had the bracket all cubed because it's a point of inflection. This one had a turning point and an intercept, regular intercept. So one that was squared and one that was linear. This one over here had linear, linear, linear. So it went through 3 times, so 3 brackets. And this one only had 1 bracket that was solvable because it only has 1 intercept. The way I draw these on paper are to put my x-intercepts in. And if it is a simple x-intercept, then I draw a vertical line, so I know that I have to go across. If it is a point of inflection or a turning point, I put a tiny horizontal line, so I know that I'm either doing a point of inflection or a turning point. And then if it's a turning point, I do a little U sometime on top of it, and then I sketch the whole graph. Thank you for watching, and I'll see you next time. Bye!